In this video, we will learn how to solve a problem on drying time. Let us have an example of this problem. A wet material is to be dried from the initial moisture content of 125% to the final concentration of 10%. Both the concentrations are expressed on dry basis. Assume that the equilibrium moisture content is negligible, means 0. The area of drying surface is 10 meters square per kg of dry solid. The rate of drying varies with moisture content as follows. Here is the data. What is the data? The variation of rate constant, the variation of drying rate with respect to the moisture content in a solid whose initial concentration is 125% and the expected final concentration after drying is 10%. This is X data versus R, that is the rate of drying. What is asked? Number A, draw drying curve. Number B, drying time for constant rate period. And C, total drying time. These are the three things which are asked to calculate in this illustration. Let us try to solve this problem. Let us concentrate on part A of the problem. What is that? It has been asked to calculate the drying time over the constant rate period. No, it's part about drawing a drying curve. So here the drying curve is drawn. It is simply R versus X, means R, rate of drying in kg per meter square hour versus X, kg of moisture per kg of dry solid. We got a curve B, C, D, E, where B is the initial moisture content is 1.25. So actually the B should start at 1.25 means somewhere in between 1.2 and 1.4, somewhere in between. This is point B. This point is x1 and its value is 1.25. This is a given value. Where is it given? 125% moisture on dry basis. So 125% means 1.25 kg per kg of dry solid. That's why x1 is equal to 1.25 and the corresponding point is this one, point B. We are able to see that the constant rate period lasts till point C, and this point C is at 0.8. X is equal to 0.8. So XC's value is 0.8. I am just reading the curve. In part A, I am not asked to locate 1.25 or 0.8. I am just reading a curve for you. Okay. So BC, constant rate period, from 1.25 to 0.8. Now 0.8 is critical moisture content and 1.25 is initial moisture content. Now the constant rate period is correspond to which rate of drying? 2.5 kg per meter square hour. So the value of RC should be equal to this value, that is 2.5 kg per meter square R. And this is the equilibrium moisture content, which is advised to be taken as negligible. Negligible means zero, near zero or zero. So that is how I have constructed the drying curve, which is an answer to part A of the question. Now switching over to the part B. What is part B? The time of drying in constant rate period. That was the part B question. Part B of the question. So what is the formula? We know. We have already studied the formula to calculate the drying time over the constant rate period. And that is theta is equal to S divided by ARC into x1 minus xc. Because, why xc? Because the constant rate period lasts till point xc from x1. So you just have to put the values. S1. All values are given per kg of dry solid. What is S? S is the mass of dry solid. Per kg of dry solid means 1 kg of dry solid. So 1. A is area of the dry surface per kg of dry solid. And it is 10 meter square per kg of dry solid. Means 10 divided by 1. So 10 divided by 1 is 10. Because by 1, 10 divided by 1 by 1 is this S per kg of dry. So 1 divided by 10 into 2.5. Where did we get 2.5 for RC? From the drying time. 2.5 multiplied by 1.25, which is the value of x1, initial moisture content here, and 0.8, the value of xc, this value. Solving this, we will get 0.018 R as the answer to part B of the question. So the drying time required over a constant rate period to dry the material from x1 to xc is 0.018 R. Now switching over to part C. What is the last in part C? It's total time of drying. Total time of drying means the drying time over constant rate period and the following rate period. Constant rate period, drying time over constant rate period, and the drying time over the following rate period. Means the time required to dry the material from B to C plus from C to E. This is theta, which is represented by theta C here, and its value is taken as it is 0.018 R. As the total time of drying is theta is equal to theta C plus theta F, where theta C is taken from this value. This value is equal to theta C. Then theta F. F stands for falling rate period, and theta stands for time required for drying over falling rate period. What is the formula? It's S by A into integral x2 to xc dx by r. Now earlier we have studied if the falling rate period curve consists of two parts, the continuous line and a curve, then the formula would be like this, and this integral part has to be find out, the answer to the integral part has to be find out by using a curve. Which is that curve? 1 by r versus x curve. Here I have drawn the curve 1 by r versus x. This curve I have drawn. So the curve is like this. Why I have drawn the curve up to this point, and why I have drawn the curve up to this point? We have these values with us. What is that value? Here, x2 to xc, right? Xc value, we know it's 0.8, therefore this 0.8 is here, right? Because we are drawing the material from XC to point 1. Why point 1? Because the final moisture content should be 10%. 10% on dry basis. 10% means 0.1. 10 divided by 100. It should be 0.1. So, by calculating 1 by R values, we have been provided with R versus X values. Almost 10 values we have been provided with. From that data, we can calculate 1 by R values. So the 1 by R value corresponding to 0.1. 1 by R value corresponding to 0.1. Why 0.1? Because X2 value is 0.1. Why X2 value is 0.1? It is given in the problem. X2 is the final concentration of the moisture and it is 10%. 10% means 10 divided by 100 is equal to 0.1. So 1 by R value corresponding to 0.2, whatever may be there in the calculated sheet, that value is this one. It is almost equal to 1, 2, 3, 4, 5, 5.5 something. See, we have been provided with this data. Then X. Then we can calculate 1 by R. Right? In the problem, we are provided with R values, we are provided with X values. From this R value, we can calculate 1 by R values. Right? In values of X, somewhere we would get value of XC, 0.8. So for that corresponding value of 0.8, we would get the corresponding value of 1 by R. So this coordinate should be the corresponding 1 by R value and the corresponding X value would be 0.8. Similarly here, X2 value is 0.1 given in the problem. So whatever may be the value of 0.1 and corresponding value of 1 by R, that should be the coordinates of this point. So accordingly, all points are drawn, all points are located, and a smooth curve is drawn through all these points. From these points, 1 by R versus X data, which we would get. Okay, understood? Now what? Now I have to determine the area under this curve. What is the area under this curve? This area. This area between 0.8 and 0.1, this value is 0.1. The material has to be dried between 0.8 to 0.1 in following rate period from point C to 0.1, somewhere here. That is what the condition you are in the problem. So this area under the curve, if we calculate it, and the graph sheet, we will get is equal to 1.078. So 1.078 is the value of this integral, and this integral is a part of this equation, which is the value of QF. So you just have to put the value 1.078 in place of this multiplied by this value, which is 1 by 10. S is equal to 1, A is equal to 10. So total value of this is equal to 0.1078 hour. And you just have to add both the times, theta c and theta f. So theta c is 0.018 hour, it's here, and theta f is equal to this value, which is here. And the total will be the total time of drying, and it is equal to 0.1248 hour. In this way, the drying times are calculated if the given data is like this, R versus X.